So this project is going to be adding a couple of sensors and displays to the mini lathe to provide some useful information while I use it. Beforehand, I already 3D printed this enclosure to both hold the displays and also to protect the back of them from stray pieces of metal making contact and shorting them out. I also put together this sort of wiring harness using the wires that the displays came with, as well as a plug that I got and the sensor that the display came with. The first one that I'll be putting in is a tachometer, and it uses this Hall effect sensor, which basically takes a voltage as an input, and as magnets pass in close proximity to the end of the sensor, the voltage changes in one direction or another, and that is counted by the tachometer and changed into a readable number for revolutions per minute. So the magnet will have to go on something that rotates, and the sensor will have to go near that magnet. So, in other words, if this is 0 volts and it has 1 volt normally, every time, for example, every time the magnet passes in front of this Hall sensor, it may spike to 5 volts and then immediately go back down to 1 volt, and then as it passes again, goes back up to 5 volts, and again back to 5 volts. And so this counts the number of spikes over time and translates that into revolutions per minute. In this very similar way, the doctor can check your pulse and get your heartbeat beats per minute, but only have to count your heartbeat for 15 seconds. The next sensor is going to be this current sensor, and I intend on using this as sort of a load sensor, because the more load the motor is under, the more current it will draw, and so that way I can maybe prevent the circuit breaker from tripping if I stay under a certain load, and then that will help me just know if I'm cutting too deep or just the general health of what's going on. This is another version of this ammeter or current sensor. It was really bright initially when I first got it, and I can show that here real quick. This is just a 9-volt battery, and this is what I'm going to be using to power this whole operation. Of course, it's going to have a switch so I can turn it off when I'm not using it, so I don't just waste the battery of showing the displays. But just to show you how bright this was initially, this is the brightness. Hopefully that's not too hard to see. And so I dialed it back a little bit and made it dimmer to match the tachometer a bit better, by just taking it apart, taking it out of this housing, and it has this mostly clear cover on it, and I just took a couple of pieces of this cheap tint and just layered it on there just to darken it down a bit. The way this works is you can't have just the display by itself. You need what's called a shunt, and this is effectively a resistor with a known resistance across this metal piece right here, and it's negligible to the circuit, so it shouldn't cause any problems. But since it's known, this current meter will basically measure the voltage across this resistor, and since the resistance is known, with electricity there's a relationship where voltage equals current times resistance. And so, as with any equation, if you know everything except for one of the variables, you can solve for it. And since it's going to be measuring the voltage and the resistance is known, then we can we'll just take the voltage, divide it by the resistance that's known, and then that equals our current, which it will then display to the screen. So that will be how we can measure current and make sure we're not overloading everything or getting close to blowing the fuse or circuit breaker. And then we'll also be able to measure how fast it's turning, so we can maybe dial in, fine-tune our cutting speeds better, and also just in general see how fast this lathe can turn. It was advertised as 2,500 RPMs, but the label says only 1,500 RPMs, so we'll be able to find out. This case, I just put a little kind of hook on the bottom of this, and it takes 2 bolts there. So let's go ahead and put this together. And by the way, I'll link all of these different pieces that I'm using in the description. So if anybody wants to replicate this, it should be pretty straightforward to do. And I'll also link to Thingiverse some instructions on, or the files to download and print this out yourself. So if you want to use this same box, then you can do that, and that should be pretty easy. I got these little magnets, and I printed this box with little magnet holders down here at the bottom and in each of the corners, and my hope is that I will be able to stick this to the top of the lathe and that the magnets will hold it in place well enough so it doesn't just fall off, but still be relatively removable. And then this switch is just a standard square switch, so that can go in there and that will keep the battery going. This is the the current display, so that should just snap in like that. This is the tachometer, which also snaps in. And then using this little wiring harness that I made, we can connect the power to each one of these. Add the switch in here. And then I have this 9-volt battery holder. These take, I think, between 6 and 9 volts input. I'm going to try it with the battery and see how long it lasts. If it doesn't last long enough, or if I'm changing the battery often, then I will use one of those wall plugs with the same end on it, just with an output of the correct voltage, and that should be fine. And next is this, again, has to go somewhere to be able to, in close proximity where something spins. So this can't be inside the box, but the battery can be inside the box, and all the rest of this wiring can be. And so this is going to go, hopefully it all fits in here together, something like this. And then I'll still have to put the magnets in, but just for the visual, these will tighten down and hold the top cover on. And so this should keep everything pretty much together and protected for the most part. And then when I turn it on, it'll display the current here and the RPMs here. So now that this is put together and assembled, let's go ahead and install these other parts and see if it works. Here I'm just installing the rest of the magnets to hold it down. Next is the final assembly of the display box and testing to see how well it sticks to the lathe. Be sure to unplug the lathe before continuing because the control box needs to be opened, which will expose potentially live circuits. I couldn't find a place where the shunt would fit while still mounted to its holder, so I decided to take it off and just mount it directly to the side of the control box. At this point, I'm inserting the shunt into the circuit. It's important to note that this display is designed to read the current of a DC circuit, not an AC circuit, so it has to be installed after the controller board has converted everything to DC for the drive motor. I also removed and am repurposing the wiring from the kill switch of the safety cover to be the signal wires for the display, since the plastic shield broke off a while ago and the switch is more just in the way than anything else now. Again, just to review, I bypassed one side of the DC side of the circuit right before it goes to the motor and inserted the shunt and then connected the signal wires with plugs that can go through the case of the controller box. After everything is hooked up, I can reassemble and reinstall the controller box. With the current display hooked up, the tachometer is next. I decided to stick the magnet on the back side of the chuck tube and simply mount the sensor in the top of the rear cover. It's worth noting that I'm using a different magnet than the one that came with the display because it's smaller and stronger. I also decided to put some electrical tape over the exposed screw heads that are connected directly to the shunt. It might not be an issue, but I might try to figure out something better in the future. After reinstalling the rear cover, I tidied up the loose wires with a Velcro strap and quickly tested for any interference by rotating the chuck by hand. Once the lathe is plugged back in, it's ready to test. and it doesn't work at all. After a bit of troubleshooting, I found that the reason the tachometer wasn't working is because of the polarity of the magnet was backwards, and simply flipping it over did the trick. For the current, I had the positive and negative wires backward, and I imagine rather than reading an absolute value of the voltage, it read as negative and the display can't show a negative current. Once troubleshooted, it works great. The top speed shows not quite 2500 RPMs, but a lot more than 1500, and this may be able to be adjusted with the limit pots on the controller board. Interestingly though, the slowest speed is around 700 RPMs versus the 50 RPM shown on the label, but that again may be able to be adjusted. Thanks so much for watching, and please like and subscribe.